in 8.3, we will do multiplication and division. Okay, product and quotient. And in between, so this, let's say this is A, this is C, in between something called exponent. Of complex numbers. In trigonometry form. Okay, the first one, the product. Let the first complex number is R1 cis theta 1, and the second complex number is R2 cis theta 2. Then the product C1, C2 will be the product of the radius, the product of the magnitude, times cis of the sum of the argument. Okay, proof. C1, C2 equals to R1 cis theta 1 times R2 cis theta 2. So that is equals to R1 times R2. I think that one is easy. This guy times that guy, is it right? Becomes this. Okay. Now times cis theta 1 times cis theta 2. Okay. Now I will show that this cis theta 1 times cis theta 2 can be simplified to be cis theta 1 plus theta 2. So I want to show that this guy here equals to this. Okay, that's what I'm about to do. I will go on. This is R1, R2 times cosine theta 1 plus I sine theta 1 cosine theta 2 plus I sine theta 2. Then I will do FOIL. Okay, I will do FOIL. The first product is, now I want you to do it for me. What is the first term?
Cosine squared theta?
No, they are not the same angle.
Cosine times cosine squared theta 2.
Cosine theta 1
times cosine theta 2.
Okay, that's the first term. The second term will be cosine theta 1 times I sine theta 2. Okay, that's the second term. Now, that will be plus I times cosine theta 1 sine theta 2. That's for the second term. The third term will be this term times this term. Is it okay? Now you tell me what will that be? That's I times sine theta 1 cosine theta 2. Then the last term is this guy times this guy. That's the last term. right? When we do FOIL, that will give me I squared times sine theta 1 sine theta 2. Okay, now the thing is, I squared is equal to what?
-1.
That's -1, that's right. So I will group them, okay? Cosine theta 1, cosine theta 2. That's for this part here. I will combine that together with this, okay? Basically, I write them next to each other. Minus sine theta 1, sine theta 2. Is it okay? That's for the blue part. While for the imaginary part, I will factor the I out. Okay, I will factor the I out. So plus I times cosine theta 1 sine theta 2 plus sine theta 1 cosine theta 2. Okay, now the thing is the first two terms combine to be
The sum and difference, cosine,
cosine what? Theta 1
yeah.
plus theta 2. Plus I sine theta 1 plus theta 2. Okay, which then I can summarize to be R1, R2, cis theta 1 plus theta 2. Okay, that's the proof. So, an easy example, suppose, for example, the easy one first. Suppose that we want to find C1 equals to 4 cis 70 degrees, and Z2, the second complex numbers, is let's say 5 cis 50 degrees. Then the product C1, C2 will be 4 times 5, the product of the magnitudes. Okay. C is 70 degrees plus 50 degrees. The sum of the angles, which is equal to 20 cis 120 degrees. Okay. Example 2. Suppose, for example, I have let C1 equals to -3 plus 3 radical 3i. Let's say that's our C1, and my C2, the second complex number, be let's say, what is good? -2 plus minus 2i. And we are interested in finding find C1 times C2. The first method, the easy method, method 1, just multiply them directly. So -3 plus 3 radical 3i times -2 minus 2i. And then you FOIL that, right? The first term will be positive 6. The first term will be positive 6. And then plus the second term is plus 6i. The third term is minus 6 radical 3i. Okay, and then the last term, let me use this. The last term will be minus 6 radical 3i squared, which will then be 6 plus 6 radical 3, right? This guy becomes this, plus I times 6 minus 6 radical 3. That's if we use the regular way. We will want to confirm that we can use the same method, a similar method, using polar. Okay. Now, what is C1? Let me ask you to do this first. C1, which is -3 plus 3 radical 3i. What is that? What is the radius? And what is the angle theta? You have done this before. I would like you to do it again. So R1 is square root of -3 squared plus 3 radical 3 squared, square root of 9 plus 27, square root of 36, that's 6. While the argument theta is equivalent to tangent inverse of the y over the x. But C1 supposed to be in quadrant 2 though, because the x is negative, but the y is positive. So theta 1 is, this is, if I use calculator or if you memorize, this is -pi over 6. But theta 1 is in quadrant 2, right? So this will be equal to plus pi, that's 5 pi over 6. Okay, so my C1 will be 6 cis 5 pi over 6. Now how about R2? You tell me. What do you get?
2 radical 2.
2 radical 2. And how about the theta? And most of the time, you actually don't need to use that formulas though. Just take a look on the position. -2 is here, right? So the angle must be 225. Okay, so 5 pi over 4. You know what? Let me use degrees. So this guy here is 150 degrees. And this guy here is 225 degrees. So this is 2 radical 2 is 225 degrees. Now then, C1, C2 will be 6 is 150 degrees times 2 radical 2 is 225 degrees. This is 12 radical 2 is 375 degrees. By co-terminal, this is the same to cis 15 degrees. Okay. Now then you can use calculator to confirm this is 12 radical 12 cosine 15 degrees plus I sine 15 degrees. Okay, let me use my calculator. Cosine 15 degrees times 12 times radical 2, I get 16.39230 plus 12 times radical 2 times sine 15 degrees. I get 4.39230 I. Compare with the top here. What is 6 plus 6 radical 3? Using calculator, this is 16.39230 plus about 6 minus 6 radical 3. I get minus 6 minus 6 radical 3 is supposed to be positive. Do I get anything wrong? Give me a second. Oh, I make a mistake here. Actually, quite terrible mistake. Right? But this is true though. This is actually, I'm sorry, this is supposed to be 2 pi over 3. My bad. Good thing I do the checking. This is 2 pi over 3. Negative 2 pi over 3. I mean, negative pi over 3, which when I add pi, it becomes pi over 3, 2 pi over 3, which is 120 degrees. So that will be 345. 345 here. Here is this. I don't need to use the coterminal anymore. And this is minus. Yeah, that's what I get there, negative 4.39230I. But my mistake on my second method actually comes from here. It's not from here. That's the one that I fixed. Now I get the same answer. But the main purpose of us learning this method is actually not on the multiplication. If you just multiply two of them, it's actually easier to just do FOIL method like what I show you up here. Okay, this method is easier. This method is easier. Okay, but the purpose of us converting them into one of the big purpose of us to convert them to trig form is because of the Moivre's theorem. It says the following. If z equals to r cis theta, then c to the n equals to r to the n cis n theta. Okay, so instead of multiplying, you do the exponent. Okay, so c times c supposed to be r times r cis theta plus theta. If you multiply two same complex numbers, okay, so c squared basically r squared cis 2 theta, right? Okay, where the power of 2, then the radius you square it, but the angle you double it. Okay, now, what happened here, if you have a complex number with r theta, then the exponent c to the n, you will do the exponent for the radius, but as for the argument, you multiply by n. Okay, now, for example, how do we use this? Suppose I have compute compute let's say 1 minus radical 3i to the power of 5. So this is the way I do it. Let c equals to 1 minus radical 3i. Now what I want to do, I give you 3 minutes, maybe 2. Find out what will this be in trig form. What is the r? What's the theta? 3 minutes.
2.
2. Okay, how about the theta? It's equivalent to tangent inverse of
Is it
negative radical
300?
That's what I think also. So that's tangent inverse of negative radical 3. That's equivalent to negative 60 degrees. So you can actually use 60 degrees. You can also use 300 degrees, either one. Okay, because we know theta is in quadrant 4, right? Theta is in quadrant 4. So you can use 300 degrees. You can also use negative 60 degrees. Okay, so the r is 2 and the angle is 300 degrees. I somehow prefer negative 60 though. Okay, but let's see. So c to the 5th will be 2 cis 300 degrees to the 5th which according to the Moivre's theorem, that would be 2 to the 5th cis 5 times 300 degrees. Now then do the coterminal thing. The multiple of 360 is 360, 720, double that, 1,440, right? When you double it. So 1,500 minus 1,440 degrees, that will be 60 degrees, right? So this is my scratch work. Is 60 degrees, so this is equals to 32 times cosine 60 degrees plus I sine 60 degrees. That is 32 times 1/2 plus I times radical 3 over 2. That's 16 plus 16 radical 3 I. That's a lot faster. That's a lot faster. Now let's do some exercise. Let's do some exercise. From page 389, on page 389, I would like you to do, you try this. Okay, leave the answers in trigonometric form. Number 2, let me write the question. Maybe number 4 instead of number 2. Number 4, 9 cis 115 degrees times 4 cis 51 degrees. Just leave your answer in trig form. That's for number 4. And then how about number 20? So number 20, we have cis 18 degrees to the power of 10. And then number 28, square root of 3 plus I to the power of 4. The top one, 1 minute. The second one in maybe 2 minutes. The third one maybe in 3 minutes. Your final answer, this one in trig form. Okay, for these two here in standard form. Okay, let's say in 6-7 minutes. is the sum of 115 plus 51 degrees. That's 36 is 166 degrees. Is it right?
Yes.
Okay. Now then, for this guy here, the radius is invisible 1, right? So it will be 1 to the 10 with still 1. Cis 10 times 18 degrees. That says 180 degrees. But cis 180 degrees is cosine 180 degrees plus I sine 180 degrees. Now what is cosine 180 degrees?
1.
Negative
Almost
1.
right. Negative 1 plus I times what is sine 180?
0.
0. So this is -1. Nice answers. Okay, then number 28. What is this in trigonometric form? What is the radius?
2.
What is the angle?
30 degrees.
30 degrees. So this is 2 to the 4 cis 4 times 30 degrees, which is 120 degrees. 16 cis 120 degrees, which is 16 times cosine 120 degrees plus I sine 120 degrees. This is 16 times -1/2 plus I times radical 3 over 2. That is -8 plus 8
4.
radical 3. I. 4. Is it 4?
No.
No, you're right. You're right.
It's 8, right? Okay. Now that's for the product and exponent. Now, for the division, part 3, for the division, it's actually a very similar idea. When we multiply, we take the product of the radius and then add the angles. But if we divide, we actually divide the radii and subtract the angles. So C1 over C2 will be R1 over R2 cis theta 1 minus theta 2. Okay. Now, for example, first example, suppose I have 30 cis 80 degrees over 5 cis 50 degrees. Now then this will be 30 over 5. That's for the modulo. Right? And then as for the angles, that will be cis 80 degrees minus 50 degrees. That is 6 cis 30 degrees. Is it okay?
Yeah.
Now, I guess I will just go ahead with the combo. This is the main part of this question, this section, the combo. Suppose, for example, I have radical 3 plus I to the 4th times 2I to the 5th over 1 plus I to the 10th. This is number 48. Now, what we will do is I will convert each one of these into trigonometric form. Okay, that's what I want you to do. You do that, I do that too. Okay, now you do it. Okay, so what will that be to the 4th? What will that be to the 5th? What will that be to the 10th? And then after that, you do the Moivre's theorem. Okay, and then you multiply and then you divide. Basically, you add the angles, you subtract the angles. Let's do the blue one first. Let's do the blue one first. What's the radius?
2.
Huh? What?
2.
2.
2. How about the angles?
30.
30 degrees. Okay, how about the second one? 2i. 2i is here. So what's the radius?
2.
What is the angle?
90.
90 degrees, good. Okay, and then how about the third one?
Radical
The
2.
radius is radical 2, the angle is
45.
45 degrees. Now then, we apply the Moivre's theorem. Okay, the Moivre's theorem, then I will get 2 to the 4th here, says 120 degrees. Is it okay?
Yeah.
Times 2 to the 5th, says 450 degrees. Over, what is this? The bottom. Radical 2 to the 10. Radical 2 to the 10 is 2 to the power of 1/2 to the power of 10. That's 2 to the 5th, which is what is 2 to the 5th?
32.
That's 32. That's right. Oh, you know what? Let me just write it as 2 to the 5th. Why I'm working so hard? So C is what?
450 degrees.
450 degrees. Oh, to my surprise that the yellow one and the green one cancel exactly. Ah. Do you think so?
Yes.
Right? Okay, so we have equals to 16 cis 120 degrees. I think we did that earlier. Exactly the same number. Oh, yeah, 16 cis 180. So this is -8 plus 8 radical 3i. So you see the procedure, let me write it in blue. The procedure basically, you start with the standard form. You convert that to trig form first. That way then we can use the Moivre's, the product or quotient, right? And then we will simplify, we will get the trig form, and then we change it back into standard form. That's the plan. Okay? Now, let me ask you to do a harder one. How about number 50? How about number 50? The question is 2 plus 2i to the 5th, and then -3 plus 3i to the 3rd over radical 3 plus I to the 10th. 1, 2, 3, 4, 5, 6, 7, 8. 10 minutes, let's say, together with your break, 10 minutes. We come back at 8:25.
Professor, we can't hear you.
I'm sorry. I'm sorry. Yeah, well, can you follow me so far?
Yeah.
Okay. Let me combine these. This is 2 to the 9 on the top, 2 to the 10 at the bottom. So that will be 27 over 2, right? Cis, you know what? Let me make it cosine 330 degrees plus I sine 330 degrees. Cosine 330 is positive radical 3 over 2 plus I sine negative 1/2. Okay, so this will be 27 radical 3 over 4 minus 27 over 4i. I know that's a long process, but it's much better than you need to FOIL this 5 times, FOIL this 3 times, and FOIL this 10 times. You see what I mean? And you still need to FOIL too many FOILs. So using this, the Moivre's method combined with the product and quotient is actually a much better method. Okay, that's for number 50. Now let me continue. Suggested homework. Suggested homework for this 8.3 will be number 1 to number 49. Maybe I do it this way. Number 1 to number 15, every other odd. That's not so important. Okay. Number 17 to 37, do the odd ones. And then 37 to 45, every other odd. Kind of like just try to do it. Okay, and then 47 and 49. Okay. Now that's for 8.3. Let's go on to 8.4. I plan to do 8.5, but looking at the time I have, I think I can do 8.4, at least the majority. 8.5 is super easy. 8.5 is super easy. 8.6 will be quite difficult. I'm somehow afraid that you get confused. So let me do 8.4 first. Okay, let me do 8.4 first. 8.4, that is the root of a complex number. Roots of a complex number. Here's the idea. Here's the idea. We already have from the Moivre's theorem saying that if C equals to R cis theta, then C to the n equals to R to the n cis n theta. You see, right? Now, it turns out that n does not have to be would be an integer. Okay, it doesn't have to be an integer. In fact, we can see it this way. We want to see that this actually works backward. Okay, we can go backward. Okay, we can go backward. In what sense? In what sense? So you see, if I call this, let me call this W. Let me call that W. So C to the N. If I call that W, which is R to the N cis and theta, okay, then the nth root of that, basically I do the nth root here, and I divide by n here. That's not really a nice way to look at that though, but I just want to show you that, if you do the nth root, you basically undo the procedure. Instead of taking it to the power of n, you do the nth root. Instead of multiply the angle by n, I divide the angle by n. Okay, that's what we are going to do. So here's the thing. I will try to go backward this way. Let W equals to R cis theta. Okay, then the nth root of W, is equal to W to the power of 1 over n. Let me just keep it C instead of W. I don't want to confuse you too much. So let's keep this C. So the nth root of Z, which is the same to C to the power of 1 over n, that's the same to doing this to the power of 1 over n, which will be R to the power of 1 over n cis theta plus 360 degree m of k over n. Because theta is coterminal to theta plus 360 degrees, right? Is coterminal to theta plus 2 times 360 degrees and on. They are all coterminal, right? Theta plus 360 degrees k. Now, when you divide by n, you divide this by n, divide this by n, divide this by n, divide this by n. That's how we get that last expression. Okay, now the thing is, then you will see that this nth root of Z actually has K solution, where the K will be from 0 up to n minus 1. Now I know the notation seems to be hard to see. Don't worry about it. Once we do the procedure, then you will see what actually happened. Suppose, for example, I have x cubed minus plus 1 equals to 0. Solve for x. Of course, this x can be a complex number. This is what I will do. So solution. x cubed equals to -1. Right? I solve for x cubed. And I will re-express this using a complex number, which is 1 cis 180 degrees. Right? Take a look. -1, the position is here. Right? The distance, the modulus is 1. The angle is 180 degrees, right? Now then, so my xk will be the cube root of 1 and cis 180 degrees over 3. Don't forget 360 degree k also over 3. You can see it this way, that this guy is coterminal to 360 degree k here. Right? So I do the cube root for the radius. For the angle, I define. Okay, so xk will be 1 cis 60 degree plus 100 degree k. Now, because this is a polynomial of degree 3, then there has to be 3 solutions. Degree 3 implies there are 3 solutions. Now, where are those 3 solutions? Coming from the k. When k equals to 0, when k equals to 1, when k equals to 2. When k equals to 0, k equals to 1, k equals to 2. When k equals 0, x0 is cis 60 degrees. x1 cis, when k equals to 1, 180 degrees. And when k equals to 2, there's another one that is cis 300 degrees. If we take a look on the position, if we take a look at the position on a rectangular coordinate system, now you will see cis 60 degrees is here. The angle is 60 degrees here. Okay, 180 degrees, the angle will be here. And then 300 degrees will be here. What I want to show you that they are separated by 120 degrees each. Okay, which comes from 360 degrees divided by 3, the power 3. That's how we get it. Okay, let's try another one. Let's try, for example, what is good? Let's try this one first. Number 4. Number 4 on page 395. Find 2 square roots for each of the following complex number. So for number 4, we have 9 cis 310 degrees. Let's call this c squared. which I can rewrite as 310 plus 360 degrees K, right? So when I do apply the square root here, I will apply the square root here, and I will divide the angle by 2. So C equals to 3 cis 155 degrees plus 180 degrees K. Now there are two solutions because it's degree of 2, right? That's degree of 2. There are two solutions. So what are those two solutions? When K equals to 0 and K equals to 1. When K equals to 0, C equals to 3 cis 155 degrees. This is 3 cis, if I add 180, 335, 330 degrees. That's it. Okay, now if I need to write this in standard form, I just will go on further. Oh, this is equals to 3 cosine 155 degrees plus I sine 155 degrees. You see what I mean? Okay, and if they are special angles, then you need to use exact value. Okay, let's try one more, or maybe two more. Number 8. Number 8. The question is find 2 square root of, or c squared equals to negative 2 plus 2i radical 3. Find what c equals to. Solution. Rewrite that radical negative 2 plus 2i radical 3. Write this in trigonometric form first. Okay, 1 minute. What's the radius?
4.
Radius is 4. C is what? So this is negative 2. This is 2 radical 3. So it must be the 60 degree thingy. This is 60 degree here, right? So this must be 120 degrees. Which I will write as 120 degrees plus the coterminal. Okay, so z will be square root of 4, which is 2. C divide this by 2, 60 degree plus 180 degrees K. So for K equals to 0, Z will be 2 cis 60 degrees. For K equals to 1, Z equals to 2 cis 240 degrees. This is 2 cosine 60 degrees plus I sine 60 degrees. That's 2 times 1/2 plus radical 3 over 2i. That's 1 plus radical 3i. I believe for this one here, I go the opposite. I will be negative 1 minus radical 3i. Now, the reason I can do it fast enough for the last one is because of the following. Notice that 2 cis 60 degree, 2 cis 60 degrees here. Right? This is 60 degrees. This is 2. Right? Now then, for k equals to 1, remember you in this case you add 180 degrees. You add 180 degrees, but that gives us the opposite, right? That gives us the opposite. That's why I can compute it that fast. Now, it is not always true though for other degree, for other root, but for square root, then the period becomes 180s, right? So we just get the opposite in this case. Your turn. Number 16. You see number 16 is good. Yeah. Now number 18 is better. Find cube roots of -4 square root of 3 plus 4i. Okay, 1, 2, 3, 4, 5, 6, 6 minutes from now. This is equals to what? In trigonometric form?
8 cis 150 degrees plus 360 degrees K.
Okay, plus 360 degree K. So the C will be the cube root of that. Okay, so that's the cube root of 8. C is 50 degrees plus 120 degrees K, which is 2 C 50 degrees plus 120 degrees K. So I hope you see the reason why I wanted you to write it in cis, because if you don't save your space using this, there will be a very long statement here, right? It will be you need to write that as, don't write this down. Don't write this down. This is 2 cosine 50 degrees plus 120 degrees K plus I sine 50 degrees plus 120 degrees K. That's way too long. Okay, and you just need to do it 3 times, 4 times, and you get scared already. You know, so that's why I wanted you to write it in form of cis. Now then, when k equals to 0, the root is 2 cis 50 degrees. When k equals to 1, that's c equals to 2 cis 170 degrees. And when k equals to 2, c equals to 2 cis 290 degrees. Okay, you just leave it in trigonometric form, but if I want you to make it into standard form, I hope you know how to go on from there. Now let's do one last question. Number 26. Number 26. Solve x to the 4th plus 81 equals 0. Solution. I rewrite it as x to the 4th equals to negative 81. And then re-express this as trigonometric form. 81 cis what? What is the angle?
180.
180 degrees. Okay, let me erase that a little bit so that I have space for my coterminal. then x will be the fourth root of 81 is 45 degrees divided by 4 divided by 4. So when k equals to 0, x will be, what is fourth root of 81? That's 3. Right? 81 is 3 to the 4th. Okay, so 3 is 45 degrees. When k equals to 1, x is 3 is 135 degrees. When k equals to 2, that's 3 is 225 degrees. And when k equals to 3, how far do I need to go, by the way? Up to k equals to 4, is it right?
Yes, because there's 4, to the power of 4.
Yeah, to the power of 4, but you start from 0 though.
Yep.
Yeah, so you will go up to 3 only. Okay, you will go up to 3 only. And if we take a look on the position, this is 3 is 45 degrees. 3 is, oops. 3 is 135 degree will be here. 3 is 225 degrees will be here. 3 is 315 degrees will be here. If you go k equals to 4, you will go back here when k equals to 4. Okay, now then let's see what will the value be here. This is 3 radical 3 over 2 plus 3 radical 3, I'm sorry, 3 radical 2 over 2 I, and this will be negative 3 radical 2 over 2 plus 3 radical 2 over 2i. This will be negative 3 radical 2 over 2 minus 3 radical 2 over 2i. This is 3 radical 2 over 2 minus 3 radical 2 over 2i. So just work it out. When you work it out, then you will see these are the answers. Okay. Now suggested homework from here will be 8.4. Will be from number 1 to number 29. Just do every other odd, that's good enough. Because this 8.4 is actually the consequence of 8.3, the Domolfus theorem. Okay, that's for 8.4. Now, in the next 15 minutes, I will give you, I will do a bit of 8.4, which is actually the majority already. 8.5. 8.58. 8.5a. 8.5 is polar coordinate system. Polar coordinate system. Basically, so far we use rectangular coordinate system in which the position of a coordinate is expressed by x comma y, where the x is how far you go to the right, and the y will be how far you go up from the origin. Is that right? Now that's the rectangular coordinate system. That's the rectangular coordinate system. Now, in polar coordinate system, we will look at the same position, but express that using, instead of how far we go to the right and how far we go up, we will express that by the angle from positive x-axis and how far we go from the origin. So this will be the radius, and this will be the theta. Okay, so later on we will express this using r theta, and I will use subscript p for polar to distinguish that from coordinate in a rectangular coordinate system. Now, the reason I say I can go over this pretty fast, because what will happen here is exactly the same thing what happened with the complex number, the trigonometric form of a complex number. Notice that x is equals to r cosine theta, and the y is r sine theta. And on the other hand, if I know the x and y, then r equals to the square root of x squared plus y squared. That's the modulus in complex number. And the angle theta is equivalent to tangent inverse of y over x. I go over really fast right now because it's basically, again, it's, maybe I write it down so that you get a bit not too anxious. The same to complex number in standard and trig form. Okay, in standard and trigonometric form. So in the next couple minutes, I will explain to you how to first convert. Okay, how to do the conversion. Suppose for example, I pick question number 4. Number 4, graph the position of 4, 135 degrees. 4, 135 degrees. So let's say this is the pole, the positive x-axis. Okay, now I will go 135 degrees. 135 degrees. Okay, but the distance is 4. So this is 4, 135 degrees. How do we get that? If the distance here is 4, and if the angle here is 135 degrees. Okay, how about number 8? Graph -4, 60 degrees. So let's say this is my pole. That's the polar axis. Okay, and I will do 60 degrees angle. I'll do 60 degrees angles. Okay, but the radius is negative. The radius is negative, which means I will shoot backward 4 units. Okay, which means I will shoot backward 4 units. Instead of going to that direction, I go to this direction. Okay, instead of going to that direction, I go to this direction here. Okay, so this is the 60 degrees, right? Now I'm supposed to go 4 units there. Okay, but because it's -4, I go backward 4 units instead. Okay. Now, how to convert this into rectangular coordinate system? In rectangular coordinate system, if I need to convert it to rectangular, then my x will be, for number 4, will be 4 cosine 135 degrees. My y will be 4 sine 135 degrees. That will be 4 times negative radical 2 over 2, negative 2 radical 2. And this is 4 times radical 2 over 2. Sine is positive in quadrant 2. This is 2 radical 2. So 4 comma 135 degrees in polar is the same to negative 2 radical 2 to radical 2. For the one here, the x will be negative 4 cosine 60 degrees. And the y will be negative 4 sine 60 degrees. This is negative 4 times 1/2. That's negative 2. This is negative 4 radical 3 over 2. That's negative 2 radical 3. So the coordinate in polar, negative 4 comma 60 degrees, is the same to negative 2 comma negative 3 radical. Now, what happens if we go backward instead? Suppose I do number 34. I have this coordinate, 2, negative 2, radical 3. Again, you can mimic this as if you are dealing with the complex numbers 2 minus 2 radical 3i. You can think of it that way. You can think of it that way. Okay? So if that's the situation, what is my r? R equals to square root of 2 squared plus negative 2 radical 3 squared. What's that?
Four.
That's 4. And how about the theta? That's tangent inverse of negative 2 radical 3 over 2. That's tangent inverse of negative radical 3. That's negative 60 degrees. However, I know my theta is in which quadrant? The x is positive, the y is negative. It's in quadrant 4. Right? So, what is the angle then?
300.
Theta equals to 300 degrees. Okay, which actually you can use negative 60 degrees because they are coterminal. Okay, so 2 comma negative 2 radical 3 is equal to 4 300 degrees in polar. Okay, now that's basically what I want to teach you today, but I need you to do this suggested homework though. I hope this 8.4 is not too hard. You can postpone doing the suggested homework for 8.4. For 8.4, if you want, you can wait until Thursday. But the one I really need you to do is 8.3 and 8.5. The first part of this 8.5. Okay? So 8 suggested homework for 8.5a. 8.5a will be number 1 to number 40, I guess 47. Yeah, up to number 47. Just do every other odd. You will see they are quite similar to 8.2. Okay, but here's the thing though. On Wednesday, I want to take some time to explain to you what will happen. On this Wednesday, I will finish the material on this 8.5. I don't think I have, and I will do 8.5b and 8.6. Okay, now 8.6 will take some time. Okay, 8.6 will take some time, and I will post a handout on our discussion board today for you to print. Maybe print like 5 or at least 5. That's a polar coordinate system. Let me see if I have that here so that you know what I want you to print out. Give me a second. This one. Give me a second. I know I have it. I just don't remember where I put it. Okay. Some. Oh. Oh, I need to look for it. I don't have it here. Where did I put it? Silly me. Silly me, silly me, silly me. It's somewhere. I just remember where I put it. Well, let me come back here. So I will have a handout. I will say print at least 5. I will say print at least 5. Because in 8.6, we will learn to graph some polar coordinate system. Okay, some polar coordinate system. And here's what will happen. So this Wednesday, I will finish the material. Finish the material this Wednesday. The material this Wednesday. And Monday we don't have class, right? Next Monday, the 25th, that's Memorial Day, no class. Now next Wednesday, the 27th, according to my syllabus, your test 4 will be on June the 1st. This is your test 4. So we can do review here for your final. Or we can switch that, where we do test 4 next Wednesday, not this Wednesday, but next Wednesday, and then review for final on the Monday after.
I'd rather switch it.
Repeat it again.
Switch it.
So you want Wednesday, next Wednesday to be your test?
Yes, so we can review Monday.
Okay. Here's the thing. Originally, I thought that next Wednesday is your test, is our test 4. Okay, that's what I thought. And then when I look at somebody asked me the syllabus today, when is our test 4 according to the syllabus for my calculus 2 class, then I figure out that my test 4 is actually Monday the 1st. Now, so the reason I asked you if you want to switch is not because I already finished the material. Actually, that's not really it. Because on Wednesday, the 3rd, this is not our final. Okay, I'm supposed to be online. I'm supposed to hold my class. No new material, so I still can do review here for your test. Okay, your final will be on the 8th. This is when your final will be. Okay, so on Wednesday, June the 3rd, I will still do review. Okay, my problem is if I keep the test on the Monday, there is a chance that some of you have a final on Tuesday, because the final week actually starts on June the 2nd. Okay, and having a test on Monday evening is quite dangerous. So I myself then prefer to change our test day to the 27th. Will you be okay with that first?
Well, I'm okay with it.
Okay, anybody not okay? Nobody
So
say
we're
anything?
moving it to Wednesday?
Repeat again?
27th, right? We're moving it to Wednesday, right? 27th?
Yeah,
test?
that's what I propose you to do.
That's fine.
That's fine? Okay, so this Wednesday I will finish the material. On Monday we have no class. And then Wednesday next week we have test 4. And then the Monday after that, the Wednesday after that, we basically do review. Okay. Of course, I will have to be in class for this time. Okay. But what a lot of instructors don't know is that because this is an evening class, then the final should be done on the last time, the last day of the week for that is actually in our schedule. So my schedule is Wednesday or Monday, right? Then my final has to be here. My final by the rule has to be there, but then the first meeting of that final week, I have to be attending the class. I don't need to do anything. Okay, I don't need to do anything. But of course I will just say review. But don't forget, when I say review in this case, I'm not going over problems in class. You ask me question, then I will go over that. Is it okay? If you don't ask me any question, I will not answer any question. Okay, so we agree that our test 4 will be on Wednesday, the 27th. Okay, this Wednesday, I will do graphing of the polar coordinate system. Okay, that's for today. That's why I want you to actually focus on 8.5. I'm sorry, did I say 8.5? Yeah, so focus on 8.5a and 8.3. You can do 8.4 later if you want to. Okay, but of course, if you have time, because 8.3, 8.5a's are easy, then go with that 8.4. Okay, that's for today.
This test 4 is where you're going to grade us on test 4 is 7.5.